This one is Geometry, Semester 2. It is the unit on Pythagorean review. It's the second lesson, Perfect Squares, Radicals, Rationalizing Practice. It's on creatormath.com under the Geometry tab. You might have to type in creatormath.weebly.com to find it in Google. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So go to that table of contents. I show it on other videos. I'm going to go straight to these problems on this one, right? What's the square root of 1? So remember, square root symbol looks like this. There's technically 1, 2, 3, 4 parts to the square root symbol. 1, 2, 3, 4. That's how many. You'll see me do it really fast, right? It starts to get rounded off in the corners. But this is square root of 1. That's what number times itself equals 1? Well, 1 times 1 is 1, so it's got to be 1. All right, what is the square root of 9? Square root of 9 looks like this, 3, because 3 times 3 is 9. What is the square root of 16? And remember, this is a review lesson, so a lot of you are going to go, yeah, I know all about this, right? And that's great. That's the whole point of a review lesson. You can go right through it and go, oh yeah, this stuff is easy. 4 times 4 is 16. This one's actually got the little square root symbol from the computer. Sometimes the computer does not put in this top part like that, so they'll just do this sort of, well, how do they do it? They do like this, 81. That just means this whole thing, right? This part they drop off. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. This is my kind of assignment. This is my kind of set of problems. Okay, now, they go the other direction. They say 1 squared. So we would write this 1 squared, but in the computer we use this caret symbol, right? So we say 1 caret 2 means 1 to the power 2. Well, that's 1 times 1, which is 1. What's 2 squared? 4. What is 3 squared? And they're mixing it up for us a little bit and just saying the word squared. 3 times 3 is 9. What is 2 to the power 3? So this is 2 times 2 times 2, right? 2 times 2 is 4. 4 times 2 is 8. So 2 to the power 3 is 8. What is 3 cubed? 3 cubed is 3 to the third power, which equals 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Cubed, why is it called cubed? Because it comes from a three-dimensional shape. This is how we calculate the volume of a cube. We do length times width times height. Width is a unit to the power 3. So that's why the power 3 is called cubed. So we use a cube sort of as that idea. All right, what is the cubed root of 125? So cubed root puts the cube out here of 125. This is what number times itself 3 times is 125. So what we have here is 5 times 5 times 5 is what it takes, or 5 cubed. So the actual number here, there's no equals. This is 5 because we have to go the other route. So just like in all math, there's a forward and reverse. There's multiplication to go forward, and there's division to go back. There was addition to go forward, and there was subtraction to go back. Right, so just like that, you have a power. Raising it to the power 3 takes you to 125. Taking a cubed root is the reverse of that, of 125, takes you back to 5. So we have a forward and a reverse again. What's the cubed root of 64? So must be 4, because 4 times 4 is 16, times 4 is 64. What's the cubed root of 8? Got to be 2, because 2 times 2 is 4, times 2 again is 8. What's the cubed root of 1? That's pretty easy, because 1 times 1 times 1. Does 9 have a perfect square? If so, what is it? So it's called a perfect square because it is an integer times itself. It's not a decimal, right? So if you have 10 and you take the square root of it, just type it into your calculator. You're going to see right away it's not an integer. It's got a bunch of decimals after it. So there is a square root of 10, but 10 is not a perfect square because it does not have an integer root. Does 2 have a perfect square? And if so, what? No. The square root of 2 produces an irrational number. Does 8 have a perfect cube, and if so, what is it? So, a perfect cube. I would rather they say perfect cubed. I'd rather make sure and get that word root in there, because that would be the cubed root of 8, and that is 2. So yes, and I'm going to go back and fix that. I don't like that language. It needs to have the word root in there. I'll fix it by the time you get to it, okay? Does 9 have a perfect cube? Again, I'm going to go all these with root. Does 9 have a perfect cube root? So, and if it were this, right, the cubed root of 9, no, because there's not a number times a number times a number that equals 9. That's an integer. All right. Can the square root of 18 be simplified, and if so, what is it? So, this is kind of nice. Yes, they give us yes for all of them, so we know the answer is yes. The question is how. We're looking for a perfect square inside of 18. Well, so the square root of 18 equals the square root of, by the way, we can call a square root symbol a radical symbol. So it can be called radical 18 right here, or square root of 18. This can be 9 times 2, because that equals 18. That's a legal move. And we can separate it. Square root of 9 times square root of 2. That's legal, because it all comes back to this. Square root of 9 is 3, so that's out. But square root of 2 is not a perfect square, so it stays under. 3 square root of 2. And you can also say 3 radical 2. Again, this is review, so I'm really not going to take too much time. I am explaining a lot here. How about 12? Does it have a perfect square in it? Sure. 4 times 3. The 4 comes out because the square root of 4 is 2. So it's out of the, I used to have a teacher that said the house. She called the square root symbol a house, and she would say, oh, pull that, the 4 can come out of the house as a 2, but the 3 stays under because it's not a perfect square. 2 radical 3. This is called simplifying square roots, by the way. So in math, we always simplify it to the lowest level. It would be incomplete to say my answer is square root of 12. We would say my answer is 2 times the square root of 3. This is the simplified version of square root of 12. Can the cubed root of x cubed be simplified? If so, what? Yes. The cubed root eliminates the cube, and you're back to just x. They counteract each other. One's going forward, the other's going in reverse. Can the cubed root of 405 cubed be simplified? Yes, the cubes cancel each other, and we're left with just 405, I think, aren't we? I don't think this is supposed to be a cubed here, the way they're answering, because they're going 27 times 15. The cubed root of 27 times the cubed root of 15 is 3. I think this part's wrong here. This answer suggests that they wanted to say, can the cubed root of 405 be simplified? And I appreciate they've given me some help here, you guys, because I don't know my 27s or my 15s. I got to be honest with you. I would use a calculator if I needed to start to divide through 405 to see what goes into it evenly. Especially if I'm a student in your position, I would do this. So I would model it for you as a teacher. That's what you should do. So can the cubed root of x to the 6th power? Yes, it eliminates 3 of those, and you're left with x cubed, aren't you? X cubed root of x squared. Good. Okay. It's hard to read the notation. One of the x's, so it's like saying this. It's like saying the cubed root of x cubed times x cubed. One of them gets canceled here and comes out front, x. The other stays under, still being cubed by the cubed root of cube 6. The cubed root of x to the 6th power is cubed root x3 of x squared. X squared times x squared. X3 times x3. I'm not sure about this one either. I'm going to check this one, you guys. I might have to redo this one. I don't like that one either. Let's see. Can the cubed root of 405 x to the 6th y to the 4th? The cubed root of this one is 27 times 15. So cubed root of 27 is 3. Do we have that here? We've got a 3. The cubed root of x to the 6th is x squared. Yes, which is what I like better. Let's go back to this one. You still have the cubed root of both of these, right? X cubed times x cubed. The cubed root of x cubed is x. And the cubed root of the other one is x. And when you multiply them together, x times x is x squared equals multiplied together. There we go. I do like that better. So I would like to see this as x squared here. I don't like this answer. All right, let's keep going. Can the cubed root of 405, we have 3 here. This one stays, so we have a final answer of cubed root of 15 in here. The y is raised to the power 3. times y. So the power 3 comes out as a y right here. That's good. And another y stays under. Perfect. And the x squared is back to where we were in the prior problem. All right, so circle this one here. It's going to be 3 times x to the power 2 times y, 3 times x squared, y, cubed root of 15y. It's going to be your final answer. Is the fraction 2 over radical 3 allowed, why or why not? The answer is no. You're not allowed to leave a square root in the denominator. We have to rationalize the denominator. You'd have to multiply this by square root of 3 over square root of 3 and rationalize it. 2 square root of 3 on the top, square root of 9 on the bottom, which is 2 square root of 3 on top, and a 3 on the bottom. 2/3 times the square root of 3, or 2 square root of 3 over 3. All right, given this fraction with a square root in the denominator, 2, what can be done to rationalize this? Oh, good. So see what I did? I multiplied this by square root of 3 over square root of 3, which is 1. That's what they're telling us right here. What can we do to rationalize the denominator? If there's a square root of 3 in the denominator, we can multiply by square root of 3 over square root of 3. We can multiply anything by 1 because it doesn't change its value. If you take $1 and multiply it by 1, you still have $1. Given the fraction with the square root in the denominator, so 2 over radical 2, what can be multiplied to rationalize the denominator? So we're going to pick square root of 2 over square root of 2. That's a 1, equals 1, and we chose it because we want to get rid of that square root of 2 in the denominator. Given this fraction with a square root in the denominator, 1 over square root of 10, we would pick square root of 10 over square root of 10 because this is 1. And it would take care of the square root of 10 in the bottom, or the denominator position. The square root of 10 times the square root of 10 would be square root of 100, or 10, and it would literally disappear the square root from the denominator position. What is square root of 2 times square root of 2? It's square root of 4. They just multiply, and the square root of 4 is 2. What is square root of 3 times square root of 3? Is square root of 9, and square root of 9 is 3. Can square root of x squared be simplified? Yes, the square root of x squared. This one's got a 2 power on it, and if we don't write it, the default is 2, or a square root, or a 2 root. The 2 root cancels the power 2, and you get back to x. And this looks like a bunch of these from 33 on. What's the square root of 25? 5. What's the square root of 36? 6. What's the square root of 49? 7. What's the square root of 64? 8. What's the square root of 144? 12. What is 4 squared? 16. What is 5 squared? 5 times 5, 25. What is 6 squared? 36. What is 7 squared? 49. What is 8 squared? 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. What is 1 cubed? 1 to the power 3 is 1. 1 times 1 times 1. What is 4? 4 times 4 is 16, and 16 times 4 again is 64. 5 times 5 is 25, and 25 times 5 again is 125. What's the cubed root of 27? I think they already gave us this one. Let's do it again. It's going to be 3, because we would have to raise 3 to the power 3 to get 27. All right. So this is Geometry Semester 2, and it's the unit Pythagorean review, and it's the second lesson, Perfect Squares, Radicals, Rationalizing Practice. And it's on creatormath.com. Make sure you're under the Geometry tab. Hope this helps.